This special video is for Amy Daves, and this works out perfectly because I've been scratching my head, racking my brain, trying to figure out a good birthday present for Amy. And nothing says happy birthday like an algebra instructional video. So, wow, what perfect timing this is. I will just let this video be your birthday present. So, happy birthday. I'm kidding, of course. Let's get into this factoring. What you want to do here is break this up into a type of factoring, hopefully that you've already been taught. And let me just go ahead and show you another way of writing this binomial that you're given. You could write this as x cubed plus y cubed times x cubed minus y cubed. And the advantage of this is hopefully you've already been taught the special factoring that involves the sum and the difference between two cubes. And that's what we have represented here in blue. So just in case you weren't shown this, here's how you factor, just in general, here's how you factor the sum of two cubes. I'm just going to use this as like a definition. Okay, here are my two cubes. And the way I factor is by doing the cube roots of both of those terms. That's what the A and the B stand for. And then I'm going to multiply that by this first term in the binomial squared minus the product of the two, AB, and then plus the last term squared. So that's just a general, we'll call that a template that we use to do the factoring of this sum of two cubes. And then the difference between two cubes is similar. If you want to factor the difference, then you still do the cube roots, but this time we're going to subtract in this first group. And this is a little tricky, so you got to be careful. We're still going to square this first term, but notice the very first term after that is going to be addition. So if you look at these signs, they're just the opposite of each other. And the rest of this follows the same script. So using this as a guide, let's factor this first binomial, the sum of two cubes. So A and B here just represent the cube roots. So the cube roots of x, the cube root of x cubed is x, the cube root of y cubed is y. And now I'm going to make this trinomial from these two terms. Notice how this works. So this is going to be x squared. Now my next sign is minus xy, x times y. My next sign is plus, and then y squared. Okay, so now I've factored this first group, and now I'm going to work on factoring the next group, and I'll just keep on doing that. So following this procedure for the subtraction of two perfect cubes, I do the cube roots. Okay, this time it's going to be x minus y. And now I build this trinomial from these two terms, so it would be x squared. Notice the sign, be careful there, it's tricky, plus xy, and then plus y squared. Okay, and so now that's pretty much going to be our answer. I mean, we can put the terms in a certain order, but the final answer that I came up with is x plus y times x minus y. And then this trinomial, x squared minus xy plus y squared times x squared plus xy plus y squared. And I don't see any other way to factor these trinomials, either of these two trinomials. So it's kind of a long answer, but that's what I came up with for the factoring. So it really amounts to rewriting into a more familiar factoring method involving, in this case, the sum and the difference of two cubes. All right, here is that next one you gave me, and it's kind of similar. We need to think of a way of rewriting this one so that we can get into more familiar factoring methods. So what if we rewrite x to the 12th, for example, as x to the 6th raised to the second power. Okay, when you raise one power to another, you multiply those together. That's how we got x to the 12th, just another way of writing it. And now I'm going to use that special factoring method that says the difference between two perfect squares. Okay, so in general, you factor two squares, two perfect squares. I'll just call them a squared minus b squared. And you've probably seen this before as a plus b times a minus b. You just do the square roots of each. And then one binomial will be plus, the other one minus. So I'm going to use that same line of thinking here. The term that's being squared is x to the 6th. So when I factor this difference between two squares, it's going to be x to the 6th plus 1 times x to the 6th minus 1. Okay, now we're going to try to rewrite this into more familiar terms. So if I do this, let me just change colors. If I change x to the 6th into x squared raised to the 3rd power, well, now I'm back to that special factoring that we just talked about using the sum of two cubes. Okay, and again, I'll just review that with you. Here's the sum of two cubes, and here's how it's factored. You probably have that written down. So I'm going to factor this in just a moment as the sum of two cubes. Now over here, since I notice minus, and I have a way of doing the factoring the difference between two squares, I'm going to set this up as a square. So I'm just going to switch these around. I'm going to let x to the 3rd be raised to the 2nd power. And now I can utilize this special factoring process. So it's really two different factoring procedures: the sum of two cubes for this group, the difference between two squares in this group. Okay, so we got a lot of, this is a long answer. So let's work on this sum of two cubes first. Remember, I'll just write that up again in case maybe you didn't get it done the first time. Here's the sum of two cubes, cube roots, a squared minus ab plus b squared. Alright, so we're going to follow this process. So the cube root here would be literally x squared, and then the cube root of 1 is 1. Okay, now we'll make this trinomial. When we square the first term, x squared squared would be x to the 4th, minus, you multiply these together, and then you plus 1 squared, which is 1. Okay, so all of this represents the factoring of this first binomial, x squared raised to the 3rd plus 1. Now let's jump over here and apply the difference between two squares method for factoring here. So the square root of x to the 3rd squared, that would be x cubed. So we're going to have x cubed minus 1 times x cubed plus 1. Alright, so boy, this is getting really involved. Okay, so can't factor this at all, so that's good. Really can't factor this at all, so that's good, but both of these can be factored. We've already seen the sum of two cubes, and now we're going to be able to use the difference between two cubes. So let's just write that up again. You must have been really bad to be given a problem like this. This is going to be lengthy. Okay, I'll just pull these down so we don't forget them. Okay, and now let's work on the factoring of this, and we'll just write it off to the side. So here we are, the difference between two cubes. That's going to be x minus 1. And now you do x squared here, plus multiply these together, x and 1, and then plus b squared, which is 1. That's the factoring of this first difference between two cubes. Now let's factor the second one, the sum of two cubes. That's going to be x plus 1. And now we're following this process. Square the first term in the binomial. Subtract. X times 1 is x. and then plus square the last term. Wow. Okay, let's just put it all together. So my answer is going to look like this. I don't think there's any real significance to the order. I'm just going to list all my binomials first, x minus 1, x plus 1. Okay, and then these trinomials will be listed, none of which I see a way to factor. X squared plus x plus 1, x squared minus x plus 1. Let me just double check that, make sure I got it all. X squared plus 1, x squared, or x minus 1, x plus 1, x to the fourth minus x squared plus 1, x squared plus x plus 1, x squared minus x plus 1. I think we got them all. So, wow, that was a doozy. Well, I hope this helps you, but you're free to give me a call or shoot me an email. If you have any other questions, just let me know. Have a good evening.